Hey, so I'm Hagen, and this is the first question I was given for Project 1 for QM238. So as you can see here, I'm working on question 1. The first thing I needed to do was to import pandas into Jupyter Notebook. So I imported pandas as PD. I then needed to read the Excel file which was given to me and save it as a data frame. First what I did was I used an external source and just converted it to a CSV file. So I did the pd.read underscore CSV function and then plugged in the new CSV file, and then I displayed it as a data frame. The next thing I did was to describe all of my statistical data by using the df.describe function. And it gave me some insight to my data, such as how many things there were in each numerical data, what the average was, what the standard deviation was, what the minimum value was, what the first quartile was, the median, the third quartile, and the maximum value in each binary attribute. The next thing I did was to get all the different types of data by using the dot data types or dot dtypes function. So as you can see here, all of my attributes were categorical other than quantity, unit price, and customer ID, which are binary, and those are the ones that gave us that statistical description for. So the next thing I did was to check for any missing values by using the .isNull.sum function. As you can see here, there were missing values in both the description and the customer ID attribute, and I needed to drop those. So I dropped any missing values by using the df.dropNA function. I then displayed that data frame as you can see here. I then wanted to go back in and just make sure that all of those missing values were dropped, so I ran the .isNull.sum function again, and as you can see it was 0 for everything, so there were no missing values. I then checked for any duplicate values by using the .duplicated.sum function, and as you can see here it says there were 5,225 duplicate values which need to drop, because if they're there more than one time they're not going to provide me any extra insight to my data. So I dropped those duplicates by doing the drop underscore duplicates function, and then like I did with the isNull, I ran that .duplicated.sum function again just to make sure everything was right, and as you can see here, they were all dropped. I then wanted to factorize my country attribute to turn that into a binary attribute so it could be useful in clustering, because for clustering we need binary attributes. So I factorized country by using the .factorize function, and then I display the new data frame. As you can see here, country is now a binary attribute. Also, the values that are 0 right here, these are all the United Kingdom, and the ones that say 1 right here, they were all France based on the prior information we had. So I did that same exact thing. I used the .factorize function, but instead I used it on the invoice date attribute. So now, as you can see here, invoice date is a binary number. And these numbers have ranged based on the dates. As you can see here, 0 would be 12/1 at 8 a.m. And then the later ones would be 12/9. So the next thing I did was to import Seaborn, and then I imported matplotlib.pyplot in order to create a box plot to see my outliers. So I did the seaborn.boxplot function and plugged in my data. Then I did matplotlib.pyplot.show, and then it shows me those boxes. So as you can see here, there were kind of some huge outliers for quantity. That's why the graph is so stretched out. So I went ahead and dropped those. Firstly, I defined the first quartile. I defined the third quartile. I used the quantile function for those. Then I defined the interquartile range by subtracting the third quartile from the first quartile. I then set my threshold as 1.5. I defined any outliers which were outside of the interquartile range and the threshold. And then I dropped those outliers for that quantity function. And then I wanted to go ahead and drop the unit price function because I felt that would be important in my clustering. So as you can see here, I did the exact same thing other than I just put in unit price instead of quantity. I then created a scatter plot. I used unit price as my x value, quantity as my y value, and then invoice date as the hue. And as you can see, there are all different dates with all different quantities and unit price, but it's fairly concentrated, as in there's not all of the prices of the items, mostly under $7, and most of the quantities are under 25. So there's not a huge difference in that data, so I think that would make it harder to cluster, which we will get into later. So the next thing I wanted to do was normalize my data set. So I went ahead and imported NumPy as NP, and I imported a standard scalar, sklearn.preprocessing, which I will later use to normalize my data. First, before I did that though, I went ahead and dropped some of the binary attributes some of the categorical attributes that aren't able to properly be converted to binary attributes because it just wouldn't make sense. So I dropped the invoice number attribute, stock code attribute, and the description attribute by using the .drop function and setting the axis as 1. And then, like I said, which I needed NumPy and standard scalar for, I normalized my data set. I set x as the values, and then I did cluster data set by using standard scalar .fit underscore transform, and then as you can see here, here's that clus data set. The next thing I did was actually I did the elbow method to predict the number of clusters. So I imported k-means right there. Then I used the elbow method to predict the number of clusters. As you can see here, I did the SSE equals k-means. I did k-means.fit, and then SSE.append. Then I converted those results into a data frame, and then I used the pyplot library in order to display that data frame, and then I visualized it by using cluster, number of clusters, and inertia. And then it gave me this right here. You can see 3 kind of acts as the elbow, separating these this lower arm and then this upper arm right here. So I chose to use 3 as my k number, or the number of clusters I will be using. I then cluster that data based on a cluster num of 3. I had to import k-means first, which I already did. I guess I can delete that. And then I got k-means by doing the init k-means. I used k-means.fit to fit the model to my data. I did df clus k-means by setting that to the labels, and then I selected the data types, including the numerical data, and then I grouped that data by the mean, which would allow me to see kind of, I guess, the centroid in each cluster. As you can see here, it was divided into 3 clusters, like I wanted. Cluster 0, Cluster 1, Cluster 2. Cluster 0, it had invoice dates, which were mostly in very early September. As you can see here, the invoice date is low. Cluster 1, it was more mid-December. Well, not really. All of them were kind of early December, but it was more It was later in the range of dates. Um, and as you can see, it also leaned heavily towards our French customers, with about 80% of those customers being French. Customer cluster 2, or the last cluster, it was in the later December towards the 9th. As you can see here, it had a late average invoice date. The next thing I did was print inertia, um, to kind of see how off our clustering was, and we got a very high inertia score. And like I said before, let me go back to that scatter plot. I think the reason for this is that all the data was clustered and concentrated so closely together. I think that's why I got a high inertia score, because it was extremely hard to cluster since the data was all very large and very concentrated together. Thank you.